Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a rational inequality. The given inequality is x squared minus 16 over x squared minus 4x minus 5 greater than 0. The first step is to factor the expressions in the numerator and the denominator because we want to find the x-intercepts and the vertical asymptotes in this rational function. In the numerator, we can use difference of squares factoring method. Square root of 16 is 4. So we can write the numerator expression in factored form as the denominator expression is a simple trinomial. We can use sum and product method to factor it. We have to find two numbers whose sum is negative 4 and product is negative 5. We should focus on the product number to find the two numbers that satisfy these two requirements. Two numbers that multiply to negative 5 are negative 1 and 5. Negative 1 plus 5 is equal to 4. But we are looking for a sum of negative 4. So we should flip the sign on these two numbers. So the two numbers are plus 1 and negative 5. We can use these two numbers to write the denominator expression in factored form. The factored form is x plus 1 times x minus 5. There is a 0 on the other side of this inequality. So now we can find the x-intercepts and vertical asymptotes. Let's start with x-intercept. We should set the factors in the numerator equal to 0 and solve for x. The first x-intercept is negative 4. The second x-intercept is positive 4. Now we can find the vertical asymptotes. We should set the factors in the denominator equal to 0 and solve for x. The first vertical asymptote is x equals negative 1. The second vertical asymptote is x equals 5. Now we can use the number line method to find the solutions for the inequality. We should show the values for x-intercept and vertical asymptotes on this number line. These 4 points divide the number line into 5 parts or intervals. We have to use a test value in each of these intervals to check whether the inequality is satisfied in that particular interval. On the left side of negative 4, we can use the test value negative 5. Between negative 4 and negative 1, we can use the test value negative 2. Between negative 1 and 4, we can use the test value 0. Between 4 and 5, we can use the test value 4.5. And to the right side of 5, we can use the test value 6. The vertical asymptotes are at negative 1 and 5. We don't need to do the check for x equals -1 and 5 because at these two x values, the rational function will become undefined. For the given inequality, we have to find the x values where the rational function is greater than 0. At x equals -4 and +4, the rational function is equal to 0. So we know that x equals -4 and +4 will not be part of the solution for this inequality. Now we can start testing the inequality in each of the 5 intervals. Let's start with the interval on the left side with test value -5. We can sub in x as -5 in the given rational function expression or the factored form. We will get the same answer. For this analysis, I'll use the factored form. In the numerator, -1 times -9 is +9. In the denominator, -4 times -10 is +40. This fraction has a positive value. Therefore, the inequality is satisfied in the interval on the left side of -4. Now we can use the test value -2. In the numerator, 2 times -6 is -12. In the denominator, -1 times -7 is +7. This fraction has a negative value. That means the given rational function is less than 0 in the interval between -4 and -1. So this inequality is not satisfied in this interval. Now we can use the test value 0. In the numerator, 4 times -4 is -16. In the denominator, 1 times -5 is -5. This fraction has a positive value. Therefore, the inequality is satisfied in the interval between -1 and +4. Now we can use the test value 4.5. In the numerator, 8.5 times 0.5 gives us a positive value. And in the denominator, 5.5 times negative 0.5 gives us a negative value. This fraction has a negative value. Therefore, the given inequality is not satisfied in the interval between 4 and 5. Next, we can use the test value 6. Ten times 2 is 20. In the denominator, 7 times 1 is 7. This fraction has a positive value. Therefore, the given inequality is satisfied in the interval to the right side of 5. Now we can use the results of this analysis to write the solution for the given inequality. The solution in inequality notation can be written as the solution in interval notation can be written as this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.